I started my lab in 2005, so 13 years ago, and since then we have been focusing mostly on the bacterial cell envelope. And in the last few years in particular, we made a number of important discoveries. I think that all the projects that we have now in the lab, they are all related to stress. So bacteria, like us, they face stress in the environment, and this stress can be caused by reactive oxygen species, by antibiotics, by an increase in temperature, for instance. And all the proteins that we study are related to the mechanisms that bacteria use to detect stress and protect themselves against stress. I would like to mention two kinds of stresses that we study. The first one is what's known as oxidative stress, caused by oxidizing molecules. And we want to understand how bacteria do to protect the envelope components from oxidative stress. And in the past few years, we have discovered two systems that bacteria use to protect envelope proteins from reactive oxygen species. That's the first kind of stress. The second one is related to stress caused by antibiotics, for instance, to damages to the outer membrane, to the peptidoglycan. And we want to understand how bacteria do to detect those stresses and to respond to them. I would like to mention the work that we did a few years ago and that we are still doing on a small protein which is called RCSF. It's a lipoprotein. It is present in the outer membrane and it functions as a stress detector in the outer membrane. So it will detect stress in the outer membrane in the peptidoglycan. And a few years ago we reported that RCSF can monitor the activity of the beta-barrel assembly machinery, and this is by monitoring that activity that it will detect stress in the cell envelope. We have two key objectives. The first one is really to try to discover new mechanisms, new concepts, to understand the molecular details of how this protein can function, can sense stress, can trigger a signaling cascade, and so on. That's the first objective that we have. The second one, and we are also actively working on that, is to use the knowledge that we generate to open the way to the design of new antibiotics, of new strategies against antibiotic-resistant bacteria.